Okay, so now we're going to factor the sum of squares and the difference of squares. And I wrote the difference of squares first because that's the one that only has real numbers in it. But the sum of squares, when you have the sum, that means it's going to look just like the difference of squares except it has bi on it. So they look very, very much alike. This is stuff that we did back in our factoring quadratics unit. All right, so let's go ahead and factor example 1. In example 1, I see x squared minus 1. It does look like a difference of squares. So it just means a plus b and a minus b. I'm just going to take the square root of x squared. That's going to give me x. The square root of 1 is 1, which means one of my factors will be x plus 1. Other factor will be x minus 1. I can't factor those any further, so this is now done. Let's look at example 2. X squared plus 4, that looks like the sum of squares. So again, I'm going to have a plus and a minus. The square root of x squared is x, so that's my first term. Square root of 4 is 2, but this was a plus. This time it was a sum, so it means I have to have an I in there this time. And now this is completely factored. And let's go ahead and go into example 3. 16x to the 4th minus 81. Well, this is the first unit where we've used factoring of with degrees that are greater than 2. So let's see. I have to find the square root of 16x to the 4th. A is going to be the square root of 16x to the 4th. Square root of 16 is 4. Square root of x to the 4th is x squared. So that's going to go here and here. I'm going to have a plus and a minus. Square root of 81 is just 9. So looks like I'm done. But I'm not, because we're still supposed to ask, can these factors be factored again? 4x squared is a squared term. 9 is a squared term. I have a sum of squares and I have a difference of squares, so I'm going to have to factor these again. So let's start by factoring this one. That's going to give me, let's see, the square root of 4x squared is 2x. Square root of 9 is 3. This is the sum of squares, so I have to have the I. So those are now done. And then this one is the difference of squares. So again, this looks almost like when I was factoring the sum of squares. So I'm going to have almost the same factors, except this one just won't have an I in it. So now this is factored fully. So it's important that you look for factoring again in case it is possible. Okay, then I had you do example 4. We had x to the 6th minus 25. Well, the minus 25, two terms, it looks like the difference of squares. What would be the square root of x to the 6th, though? So I'm trying to figure out this question. If that is x to the 3rd and I square it, I'll get x to the 6th. So that means that the square root of x to the 6th is equal to x to the 3rd power. So that's going to help me with my factoring. So the square root of x to the 6th is x to the 3rd. Square root of 25 is 5. It looks like I might have a sum and difference of cubes here, but 5 is not a cube number, so that just can't be factored anymore. So that one's done. All right, well, let's try one more example. So in example 5, I have x to the 6th minus 27, and I might be thinking, hey, it's the difference of squares again. No, 27 is not a square number. 27 is a cube number, however. So technically this example shouldn't even be on this video because it's not a difference of squares. It's actually a difference of cubes, but I wanted to show this to you. So even though I have the same power here that I have here, doesn't mean I'm going to factor it the same way. 25 was a squared number. I could treat this as the difference of squares. 27 is a cube number. I have to treat this one as a difference of cubes. So let's see, our formula for the difference of cubes was that if I had difference of cubes, that was going to give me a minus b and then a squared plus ab plus b squared. So I have to figure out what my a and my b are. Okay, well, x to some power cubed has to give me x to the 6th, so that's my 2. Okay, so that means a is going to be x squared. The b is going to be 3, and again, I'm getting these from those numbers right there. So x squared minus 3, and x squared squared, that means x times x times x times x, that's going to be x to the 4th. A times b, and then b squared would be 9. I can't factor this one any further. It looks like a difference of squares at first, but 3 is not a square number, so that one is actually done. If I took a look at this one, my a value is 1, c value is 9, 1 times 9 is 9. So if I were to just check to see if I could factor that, I'm looking for factors of 9. They're going to add up to 3. That's not going to happen. That can't be factored any further. So that means this is now factored completely. And I have now finished example 5. So this is factoring the sum and the difference of cubes. Both of your factors are going to be conjugates of each other, where one has a plus, one has a minus, otherwise they're the same. But if I'm factoring the sum of cubes, I'm going to have a complex conjugate involved.